everyone, we're going to find the points on the given polar curve r equals e to the power of theta and find where the tangent line is horizontal or vertical. The first thing we're going to do is find the horizontal. So that means we're going to do the derivative of y with respect to theta. So we need our y equals r sine of theta. And what you do is you substitute in your r here, so you get y equals e to the power of theta times sine of theta. Now we can differentiate our y with respect to theta. So this is going to be e to the power of theta times sine of theta plus e to the power of theta times cosine of theta. So basically I took the derivative of e to the theta, gave you that, copied that down, and then I copied this down, took the derivative. Now I'm going to factor out this e to the power of theta, and this is going to be sine theta plus cosine theta. Now for the tangent horizontal, this is going to equal 0. If you divide both sides by e to the power of theta, we're going to get sine of theta plus cosine of theta equals 0. Or you could say sine of theta equals negative cosine of theta. If you divide both sides by cosine, we get tan of theta equals negative 1. All right, now this is going to happen where theta equals negative pi divided by 4 plus n times pi. And n can be any integer. Now I'm going to rewrite this right here as factor out a pi and write this as n minus 1/4. These are equivalent expressions. All right, now to find the points on the curve where it's tangent, what you do is substitute in our values. So we have at n times n, at pi, times n minus 1 divided by 4, you just substitute this back into your original equation, and this is going to be e to the power of pi times n plus 1 divided by 4. So that's your horizontal tangent. Now let's do the vertical tangent. It's very similar. You might want to try it. We're doing derivative of x with respect to theta. So our x is our cosine of theta, and substitute in your r, which is e to the power of theta cosine of theta. Now let's go ahead and differentiate our x with respect to theta. This is going to give you e to the power of theta, that's the derivative, times cosine of theta, plus copy down e to the theta times derivative of sine of theta, which is going to be cosine of theta, which is negative sine of theta. So I can rewrite this as e to the power of theta times cosine of theta minus sine of theta, and set this equal to 0. So just like we did before, you divide both sides by e to the theta power, and you're going to get cosine of theta minus sine of theta equals 0, because we can just divide all of this out. So that just goes away. Now, so that gives you cosine of theta equals sine of theta, or you can say tan of theta equals 1 if you divide both sides by cosine. All right, since we have that, cosine of theta is 1 when theta equals pi divided by 4 plus n times pi, and n is any integer. Therefore, let me just rewrite this and factor out a pi. This would be pi times n plus 1/4. So at pi times n plus 1/4, you just substitute this in for theta. So we get e to the power of pi times n plus 1/4. And that is your final answer. Thank you. Have a nice day. Bye-bye. Baby.